Question 13. A student wants to investigate how the current through a filament lamp affects its resistance. So this is a core practical, and we've been told that the components which are used are a battery, a variable resistor, a filament lamp, a voltmeter, and ammeter. We know that ammeters are always connected in series and voltmeters are always connected in parallel. So we leave the voltmeter to draw at the end, but we'll connect everything else in a big loop in series. So there's your battery connected to a variable resistor, connected to a lamp, connected to ammeter, and back to the battery. It doesn't matter which order these three are, as long as four are connected in a loop. Then the component we're investigating, which is the lamp, will have the voltmeter around it. Okay, and that's how we draw a circuit diagram for this particular core practical. So describe how the student could use her circuit to investigate how the current through the filament lamp affects its resistance. So what we're going to do is, first of all, we need to take some readings from this setup here. So how we do this is by changing the resistance on this variable resistor, and as a result, these two readings will change. So we're going to say connect the battery, variable resistor, ammeter, and the light bulb in series. Connect the voltmeter around the lamp in parallel. So adjust the resistance on the variable resistor. This will change the reading on the ammeter and the voltmeter, and we'll record these readings on the voltmeter and ammeter. And once we've got a voltage and a current, we can calculate the resistance by doing resistance is equal to voltage divided by current. So the voltage reading, the current reading, and we'll have a set of resistances for different currents. So, or we could plot a graph of current and resistance. So this ammeter reading and the resistance we've calculated, and we see how they are affected against each other. Now we can see that the results, that as the current rises, the resistance rises, but it's slightly incomplete because we don't have the first part of the data. Now describe how the resistance changes as the current through it increases. So, as the current increases, the resistance also increases. So, we're going to estimate the resistance of the filament lamp when the current is zero point 0.1 amps. So, we're going to find zero point 0.1 amps. Okay, so zero point 0.1 amps is there. Okay, and we need to extrapolate back. So follow the curve, extrapolate back, and it hits around about just above 6. So that one small square. However, I need to know what this one small square is worth. So there's 5 small squares all the way up to 8, and the difference from 8 to 6 is 2, and we divide 2 by 5 small squares and we get zero point 0.4, and each small square is worth zero point 0.4. So that's 6 and a bit of extra, which is zero point 0.4, which is 6.4 ohms. Part E, what we are going to do is label the components that these graphs belong to. So we do the experiment for current voltage for a specific component, and we see this pattern, and that pattern is for a filament lamp. So that's an IV graph for a filament lamp. This is an IV graph for a resistor at constant temperature, and this is an IV graph for a diode.